let's talk a little bit about chemical reactions. And chemical reactions are a very big deal. Without chemical reactions, you or I would not exist. In your body right now, there are countless chemical reactions going on every second. Without chemical reactions, we would have no life. We would not even have the universe as we know it. So what are chemical reactions? Well, they're any time that you have bonds being formed or broken between atoms or molecules. So what are we talking about there? Well, this is maybe one of the most fundamental chemical reactions. Once again, if this one never occurred, we'd be in trouble. We would not have any water. But let's think about what it is actually describing. So over here on the left-hand side, we have the reactants. Let me write that down. So here we have the reactants. These are the molecules that are going to react, and then we have an arrow that moves us to the product. So let me do that in a different color. So we have an arrow that moves us to the product, or we could say the products. And so what are the reactants here? Well, we have molecular hydrogen and we have molecular oxygen. Now, why did I say molecular hydrogen? Because molecular hydrogen, which is the state that you would typically find hydrogen in if you just have it by itself, is actually made up of two hydrogen atoms. You see it right over here. 1, 2 hydrogen atoms. And what we have, in order to have this reaction, you don't just need one molecular hydrogen and one molecule of hydrogen, one molecule of oxygen. For this reaction to happen, you actually have two molecules of molecular hydrogen. So this is actually made up of 4 hydrogen atoms. So let me make this clear. So this right over here, this is 2 molecules of molecular hydrogen, and that's why we have the 2 right out front of the H sub 2. This little subscript 2 tells us there's 2 of the hydrogen atoms in this molecule, and then this big white 2 that we have right over here, that tells us that we're dealing with 2 of those molecules for this reaction to happen, that we need 2 of these molecules for every molecule of molecular oxygen. And molecular oxygen, once again, this is composed of 2 oxygen atoms, 1, 2. So under the right conditions, so you need a little bit of energy to make this happen. If under the right conditions, these 2 things are going to react, and actually it's very, very reactive, molecular hydrogen, molecular oxygen, so much so that it's actually used for rocket fuel, you are going to produce 2 molecules of water. We see that right over here. And look, I did not create or destroy any atoms. I had one oxygen atom here. It was part of the oxygen molecule right here. And then I have the second one right over here now. Now they are part of separate molecules. I had 1, 2, 3, 4 hydrogens. I now have 1, 2, 3, 4 hydrogens, just like that. And actually this produces so we could say some energy, and I'm being inexact right over here, some energy, and then we could say a lot of energy, a lot of energy. So this is a reaction that you just give it a little bit of a kickstart and it really wants to happen. A lot of energy. So one thing that you might wonder, and this is something that I first wondered when I learned about reactions, well, how does this happen? Is this a very organized thing? Do these molecules somehow know to react with each other? And the answer is no. Chemistry is an incredibly messy thing. You have these things bouncing around. They have energy. They're bouncing around all over the place. And actually, when you provide energy, they're going to bounce around even more rigorously enough so that they collide in the right ways, so that they break their old bonds and then they form these new bonds. So whenever you see these reactions in biology or chemistry class, keep that in mind. It looks all neat and organized, but in a real system, these are all of these things just bouncing around in all different crazy ways. And that's why energy is an important thing here, because the more energy you apply to the system, the more that they're going to bounce around, the more that they're going to interact with each other. The more reactants you put in, the more chance that they're going to bounce around and be able to react with each other. Now, I'm going to introduce another word that you're going to see in chemistry a lot. This water, these 2, we have 2 water molecules here. We could call them molecules, but since they are actually made up of 2 or more different elements, we could also call this a compound. So water is, you could call it a molecule or you could call it a compound. So this is a molecule or compound, while this molecular hydrogen, you would not call this a compound. And this molecular oxygen, of course, it's a molecule, but you would not call it a compound either. And just to get an appreciation of how much energy this produces, let me show you this picture right over here. That's the space shuttle. And this big tank right over here, this big tank contains a bunch of liquid oxygen and hydrogen. And to create this incredible amount of energy, it actually just you mix the two together with a little bit of energy, and then you produce a ton of energy that makes the rocket, that makes the space shuttle. Well, the space shuttle's been discontinued now, but back when they did it to make it get its necessary velocity.